Hey everyone, welcome back to Codemaster Java. In today's video, we are tackling a popular LeetCode problem and a commonly asked question in most of the MNCs: top K frequent elements. So in this video, we will break down the problem, implement a solution using the Java, and dive into a detailed explanation of how priority queue helps us to provide an efficient solution for this problem. And also, we will go through on how priority queue works with a real-time example. So, without further ado, let's get started. Top k frequent element is a medium-level problem, and here is the problem statement. Given an integer array nums and integer k, return the k most frequent elements. You may return answering. Okay, so let's look at an example. Here, the input is nums array is equal to 1, 1, 1, 2, 2, 3, and k is equal to 2. So in here, we have to return two most most frequent elements from this array. So that is 1 and 2, because the 1 comes 3 times and 2 comes 2 times in this in the num array. So now let's discuss about the solution approach. But before that, let's start by imagine how we had solved this problem without a computer. So for that, let's imagine we have a fruit basket at home, and it has apples, mangoes, and oranges. So now we have to select top two fruits such that we can select as much fruit as we can. So to do that, we should organize the basket as the basket is now arranged randomly. So let's after that we have to group the fruits by variety and count the number of units for each fruit. Okay. After that, we want to select as we want to select most fruits. So let's arrange these types in a descending order of the count. Okay. And finally, we can select first k varieties of the fruits from the sorted list and select as much fruit as we can. So, and that is our answer. Okay. So let's code this approach out and see how if we are able to solve this problem or not. Okay. So first, write down the step which we have to do. First, we have to create uh, to organize the basket and to get the frequency count, like how which element is how many times we can use a map. Okay, so we have to create a frequency map. Okay, to store the frequency of the element. After that, we have to for transform this list, sorry, this map into list, sort this list, reverse order, and after that we have to select first k element sorted list, and we will get our answer. So to store the frequency of each element, we have to create a new version of integer comma integer. Let's call this as a frequency map. Okay. Now let's look through each element of nums array is equal for each loop and try to and store uh, element as a key and its frequency as its value. Okay. So we will use map put method of map and store num element as a key After that, we will use maps get or default method to check if our element is present or key is present in the map or not. If it's present, then we will return its value. Otherwise, we will return as 0. We will increase the count or frequency by 1. Okay. After doing this, we have our map which contains its element and its frequency. So now let's transform this list into an transform this map into a list. So to hold that key and value pair into the list, we have to create one more list which store entry of map dot entry of integer or comma integer. Let's name it as a list. This is a new array list, and the input for these the frequency map dot and entry set. Okay. So by calling this method, we are able to get the collection of this key and value pair from the map, and we are storing it in the list. Okay. Now we have to sort this list in a reverse order. So okay, for that we will use we want to compare the value, right? So we will use pairing by value method. We will set the comparator equal to reverse order. Okay. So by doing this, uh, we are sorting this list in a reverse order. Okay. After sorting this list, we have to create a new integer array to store our answer. Okay. We will create a new integer array of length k. Now we will create a new for loop and loop through uh, from 0 to k, and now this by 1. Now we will store in the answer array the first k element from that list. Okay. So to do that, we will use list get method. We will get the ith element from that list, and we will get use the get key method to get the key from that particular map from the map entry set. Okay. By using this, we are able to get our answer array. We will return that answer array. Okay. So let's check our code first, and let's run it with the local test cases and see if we are able to pass it or not. Okay. Oh yeah. Oh, sorry, forgot to and y in fact. Let's rerun. Yeah, it's passing, right? So both of the local test cases are passed and it's accepted. So let's submit to check the global test cases and all the test cases. Yeah, see, it's accepted and it's taking 50 milliseconds. Uh, let's check the time complexity for this. We are look through the every element from the nums array, and we are sorting it. So the time complexity for this will be O of nlogn. Okay. So now let's optimize this approach and see how priority queue uh, helps us to solve this problem efficiently. Okay, so let's check it out. But before that, let's understand so how priority queue works and what is the means how we can implement it. Okay, so a priority queue, also known as a heap, is a sorted data structure that resembles a binary tree and is supported by an array. In practice, the tree is not shown to the caller, and we can view it as a type of self-sorted array. Typically, heaps are implemented to hold elements in either descending order, a max heap, or ascending order, a mean heap. And as elements are added or removed, the heap retains its sorted order. So it's basically just a list that is sorted every time an element is added or removed, which is why we can often use a basic list or array to represent the priority queue. Yeah, I can understand that this is a boring definition of a priority queue. So let's understand the priority queue with an example and a visualization. Okay. So first, let's define a priority queue that holds an integer. Then we do the queue. Priority queue. Okay, right now we are creating, so basically, naturally, it's a mean heap whenever we create the priority queue without a sorting order. Okay, so now let's edit the number 6 to the 1 to the 4 to 5 to. Okay, so we have added 1, 2, 3, 4, 5 elements in our priority queue. Let's shift out the priority queue to check what is the output for J. It's building, okay, it's passing 5. So it's 1, 2, 4, 6, 5. So by visualizing it, it's not a sorted array. Okay. So how it's working actually? So let's use a pull method of this and pull out the elements from this priority queue. Okay. So this is the mean heap. So every time we pull out the element from a queue, it returns a smallest element from the list. Okay, so let's check it out if it's doing this one. Okay, so let's pick the element from it. So let's rerun it, check the output. Okay. See, now it's a sorted, right? 1, 2, 4, 5, 6. Okay, now let's change the uh, order of the priority queue created the reverse order. Okay, so now we have created this priority queue as the next step. So when we run this program, run this code, it always returns whenever we with the pull method, it always returns the next from the list. So let's check it out. See, it's always returning the next element from the list. 6, 5, 4, 2, 1. Okay. Now let's visualize it how the priority queue is holding all the elements in the array. Okay, so for that go to uh, let's go to the on the window. Now let's create a random list from a random elements. Okay, copy this. Now we will go to ID. a integer variable to hold with the number for integer every number we will use to store in our priority queue so that we will be what is the option is it's sorted space and is max it. So that's why it's returning us the max element every time. So now let's change it to a min-heap, run it. Okay. Now let's visualize it. First, we are inserting an 8. Okay. So we are into the 8 number. Okay. So now it's create a node for an 8. After that, we are into 7. Okay. It's checked if the 7, as we are creating a min heap, so it is checking like 7 is 7 is greater than 8 or not. If the newly created element is currently we are creating a min heap, so it will check if it's less than or not. If it's less than, then it will change its with the root node. Now we are inserting doing 13 element. Okay. Now let's do 8. Okay. It will check here. Okay, 8 is equal to 8. There is no change in it. Now let's insert 2. It will check here and again 2. So 2 is now a root node. Okay. So now if we pull out from this priority queue, it always returns the smallest, right? So let's again with the 2. The 13 2 is present. 2 2 equal to 2. There is no need to change that. Let's insert 6. Okay. 6 is always right. 6 is also in the right place. Now 6. Okay. Again insert 6 into Q. Okay. To change that. 3. 3 is greater than 2. So there is no need to do that. Let's insert 8. There is no change there. Let's 13. Okay. Now if we dequeue this list, it will remove 2 and it will check for every time. What is it? Now it's sorted, right? Again, if we dequeue it, so every time we do any operation, add or remove, it every time it's the our priority queue is getting sorted. So this is how the priority queue works. Okay. So we have understand the its initial now of working of a priority queue. So now let's implement it in our code. So here instead of loop, we will use so the uh, uh, idea of solving this problem with the priority keys, we will use the min heap, and we only store that much of k, uh, k number of element in that list. If the size of that list gets bigger, we will pull the list element from the min heap. Okay, that is the idea. So let's try to code for that approach. Okay. This first let's initialize the priority queue. The queue. Sorry. Here we go to pass the comparator. So we need to create Min-Heap. So we will sort this in order. So open the comparator. After sorting this, we have to for loop over for each loop over entry of the its name is ending. That will be from the frequent map, frequency map dot and now we have to insert ending priority queue and if priority queue dot size is greater than k after inserting that element. After inserting that entry, if the priority queue size is greater than k, then we will pull out the smallest sequence of smallest element from that entry. That is the idea. Okay, to optimize it. After doing that, we will have the priority top k elements or entries in the priority queue or priority queue. So for that, to use to create answer array, and we need to get the queue dot pull method that will give us a first map dot entry object. Now we have to vector get key of that. Okay, that is there. So let's check it out. We are the performance is getting poor. Okay, so it's accepted. Let's check it's improved or not. It's improved. It's from 40 milliseconds to 30 milliseconds. Okay. So this is the uh, yeah, this is the approach. This is the approach how we can solve this problem using the priority queue. Okay, so the complexity of this will be big of uh, big of n log k because log um, big of n would be for this one, and we are creating a priority queue for the k element only. So for this, it is the big of log k. So the combined complexity of this is big of n log k. So which is proved from the previous one of from the brute force approach. So this is it for today's problem. So we have covered how to solve the top k frequent element problem using a brute force approach and as well as using the priority queue approach in Java. So if you found this video helpful, so don't forget to give it a thumbs up, subscribe to Podmaster Java if you haven't done it yet, and hit the notification bell for more coding tutorials. Drop any questions or suggestions for future videos in the comments below. Thanks for watching. See you next time. Happy coding.